This might sound like a bit of an outlandish title, but traditional packaging is not suitable for modern applications. Now, when we say traditional packaging, this is referring to things that you see on Arch Linux, Debian, Fedora, and various other normal distros. The typical way that you see packaging being done, where say you want to download Firefox, for example, you download the package for Firefox, and it's going to have a bunch of dependencies, whether those are other applications, libraries, fonts, and things like this. And all of these individual dependencies are their own separate package. But Firefox doesn't have exclusivity over these dependencies. If you download another browser or another application or anything else in your system and they need one of those dependencies, then they have complete reign over using them. And most distros use this model. The one thing being excluded is the Nix package manager, because while it does work in this dependency way, the rest of the package manager is different enough that it should be in its own whole separate category. Now, regardless of whether we're talking about an LTS release, a fixed point release, a rolling release, or anything else in between, all of these distribution models share one common problem. Packaging modern, complex applications is really difficult. Now, many, if not most of the applications out there play well enough in this model, whether it's a file manager, terminal, browser, or pretty much anything else. If they didn't, Linux would have this reputation of being horribly unstable. But that doesn't mean that everything works well in this model. And while shared dependencies do have their plethora of benefits, they do introduce a whole nother problem: shared dependencies. So we should all know about package conflicts. If we attempt to install Visual Studio Code while code is installed on Arch Linux, we'll run into this issue. Basically saying that they are conflicting, and if you want to install them side by side, this has to be manually confirmed. But in this case, you can't actually do so because they're both providing the exact same binary. In this case, /user/bin/code. And you'll see this with various other applications like Audacity and its various forks and things like this. And while in this case, you may not want this to happen, you don't want to have two things providing the exact same binary, in some cases, this might actually be something beneficial, like having a testing or a beta branch installed, having the Xorg and the Wayland version around, or just for one reason or another, you want to have two versions installed. And the place where this becomes really important is with dependencies. One of the biggest issues with traditional packaging is that packages cannot cherry-pick dependencies. For example, if an application recently updated and requires dependency A version 1, but the distribution only ships dependency A version 0.9, then it would not be ideal to upgrade the application, as the distribution will not meet the requirements. This means the packager will have to hold back the package until the new dependency is released for the distribution, or resort to workarounds. Likewise, if an application requires dependency A version 0.8.1, but the distribution ships dependency A 0.9, then the application can misbehave or even not work altogether. A great example of this is OBS being perpetually broken on Arch Linux. It requires a very specific version of CEF Minimal to do its browser embeds, and the browser embeds are used for docs and various other parts of the application, so it not being there is a pretty big problem. But Arch Linux doesn't have a package for that specific version, so you just cannot have that feature. The only way to get around it is to install a separate version from the AUR, or install the flatpak. But it's not always an application dependency that is at fault. Sometimes it's the fact that a distribution or an application relies on a fork of one of the dependencies. So to expand, several applications require patch libraries or additional build options to function correctly. For example, OBS requires a patched FFmpeg to neatly integrate with OBS Studio, With traditional packaging, there can only be one variant of the dependency installed at a time. If the distribution ships an unpatched FFmpeg, then there's no way to install a patched FFmpeg unless the packager works around that. If the patched FFmpeg is installed, but another application relies specifically on an unpatched FFmpeg, an FFmpeg with other patches, or an FFmpeg with additional features built in or removed, then that other application can misbehave. Modern applications are inherently fragile. One small mistake or inconsistency within the dependency tree can cause an application to misbehave and worsen the user experience, and may even give the impression that the application is at fault and not the package itself, which can hinder the application's reputation. But there are workarounds, otherwise things like Electron simply wouldn't be usable on Linux. So if you run Electron applications, it's very likely you have something from like Electron 12, Electron 15, Electron 19, and it seems entirely random. Especially with proprietary applications, a lot of them like to rely on a very, very specific version of Electron, in many cases, quite a bit of an older one. Now, a lot, if not most of these applications do bundle Electron. So when you download the application package, that includes the version of Electron it needs, rather than downloading a separate package externally. But there is still some data that needs to be saved in a general Electron location. And to get around that being a problem and conflicting with other packages, on Arch Linux, that is stored in /opt / the name of the application. So /opt / discord /opt / element and things like that. And then the second and third options are basically the same thing. Either modify the code of the application, make a fork of the application, or mess around with the build options to either remove or modify that section of the code to make it so that dependency just simply isn't needed. This is what is done to make the OBS package on Arch Linux function full stop. They disable all of the sections that rely on CEF minimal so they can compile the application, and even though those features are missing, it technically works. It is a serious subpar user experience, and there's always people complaining about it over on the OBS forums. And then pair all of those issues with the issue of distribution models. Some distributions like Arch Linux are close to bleeding edge, and thus have the latest version of packages. However, with things like Debian and Ubuntu LTS, a lot of their packages may be several versions behind, and then other distributions are somewhere else in the line, and it's really unclear from the perspective of an application developer what is available on every distro, and how to give all of your users a consistent experience. A single application is built very differently across distributions. Furthermore, dependencies are also built differently from distribution to distribution. There are tons of technical limitations with traditional packaging that require different workarounds depending on the distribution model and packaging policies. These minor changes often give incomplete, subpar experiences and wrong impressions to the user. Some applications may work better with some distributions, whereas some other applications may work better with other sets of distributions. Even though a single application is built differently on each distribution, the name and branding is kept as is, which again gives the wrong impression to users. And the solution here is pretty straightforward: containerization and Nix-style package management. Containers are designed to separate several aspects of the system. With the use of containers, packages can cherry-pick dependencies without being limited by host libraries. Packages can thus ship the latest, feature-complete builds of packages while retaining the stability of the distribution. This is really important as these container formats can push applications and distributions to their boundaries without affecting the system destructively. So considering this is a blog from the Evil Skeleton, we're obviously going to talk about flatpaks. But first up is Nix. So Nix is a cross-platform package manager to work in Unix-like operating systems like Linux, BSDs, and macOS, and Nix has several channels, branches that users can use. As for Flatpak, Flatpak, on the other hand, is a universal package format for the Linux desktop that also leverages containers but additionally sandboxes to isolate them. It is intended to be used by the average person in the future and is designed to be integrated with software stores such as GNOME Software and KDE Discover. In other words, Flatpak is more of an extension for distributions rather than a replacement, as it is literally designed to not replace system package managers. One thing he means there is it's not really suitable for packaging CLI applications. And used as an extension is the way that I think Flatpaks generally should be used. Let's say for whatever reason you want to have the beta version and the stable version of application both installed at the same time. Let's say you're trying to test one or something. Well, this is going to cover you. Each app is treated as its own separate thing, completely separate from the others. So you can install multiple branches with no issue whatsoever. And Nix handles this in its own separate way, but allows you to do the exact same thing. And because with a Flatpak it ships exactly the dependencies needed for that application in the container itself, there is no worry about having weird conflicting dependencies or weird versions that don't exactly line up the way that it perfectly should. I've mentioned the OBS example, but let's say something like Bottles or the XIV launcher. Both applications that heavily rely on Wine, and Wine can be very sensitive to the version you actually need. And rather than worrying about getting all that stuff set up yourself, exactly what is needed is shipped in the application, and the user is good to go. It doesn't matter if they're on Gentoo, Fedora, Ubuntu, Arch Linux, or anything else in between. They are going to have the exact same experience. But especially with Flatpaks, they are not without their flaws. Flatpaks not only contain an application, it also sandboxes them. Flatpak developers have implemented a short-term workaround that punches holes in the sandbox known as static permissions. These are just changing the permissions on the Flatpak. But they are developing proper long-term solutions called XDG portals. We've also talked about these very often on this channel, most notably with, screen capture over on Wayland, to address many issues regarding the sandboxing and make them act more like Android security model. So if an application wants to grab your webcam, for example, it'll ask for permission to do that, and then you let it do it, and then when you're done with that, you can then revoke the permission. But while it can all be done on the developer side, the main issue is neat integration into GUI toolkits. And while GTK and Qt have got that integration going, not everything out there that people use actually has that. And while things like deduplication do exist for Flatpaks to reduce the amount of duplicated data, a Flatpak is inherently going to take more space than a traditional system package. But as I've said for a lot of things regarding data on your system, we've gotten to the point where hard drives and SSDs are getting so much larger, but the amount of data we're storing isn't really going up proportionally to that. Unless you're downloading AAA games and 4K videos, you don't really use any more data. So if you go from having a 1 terabyte to a 2 terabyte to a 4 terabyte hard drive in a couple of years, which is going to be the standard, it's not a big deal using a couple extra megabytes. In the end, it makes no sense to push out the traditional packaging models. For most applications, it works perfectly fine. But for those applications where they will behave a lot better in a more containerized fashion, or the way that Nix does it, this is something users should be pushing developers to support. Yes, there are these third-party Flatpaks for a lot of applications, but I would love to see more developers officially supporting the Flatpak, even if it's not like the main maintainer, someone directly involved in the project, bringing those Flatpak maintainers into the project and making sure it is the best experience possible, because in many cases, even that third-party Flatpak is going to be a better experience than a traditional package. But let me know your thoughts down below. Do you use any Flatpaks or Nix packaging or other ways of handling these misbehaving applications, or do you just accept that traditional packaging is going to be here forever and I might as well just live with it and not care about any newer solutions. I would love to know. So if you like this video, remember to go like the video, and if you really like the video and you want to become one of these amazing people over here, go check out my Patreon, subscribe to the pay linked in the description down below. I've got my podcast, Tech Over Tea. I've got a gaming channel called Brodie Robertson Plays. That's going to be it for me, and I'm out.